Okay, from the previous demo, we prepped our software to start running a test. And now when you want to actually measure a cam with a cam test stand, you click on record or press F5. And here we've established communications. This thing is reading zero. Reading zero on lift and rotation, probably because the box is just powered up. If I rotate the cam, you can see I'm getting data. Now it's fairly slow updating. When we're doing a demo, the computer's trying to do two fairly fast things at once: record data and capture the screens, record the screen. For that reason, I won't necessarily get good measurements while we're displaying on the screen, while we're recording the screen. Now, when you start measuring a cam, it's not really important what these numbers are. You don't have to zero them out because the program will figure it out. For example, lift. The program's going to know when you measure a cam that when you're on base circle, that's approximately zero lift. And when you go over the nose, it's going to just know that it's 34,000, 340 thousandths or whatever, based on zeroing itself off behind the scenes. This number won't be re-zeroed, but it'll zero itself out behind the scenes. And the rotation will get figured out based on what you wanted for number one intake. For example, the first lobe we measure has to be number one. And you can see that's what it says up here, number one intake, number one intake. You see down here we're on number one intake, and up here we're on number one intake. That's because we told the program we want number one intake to be 102 degrees. And once we know that, we measure intake number one, then we know what the rotary encoder is zeroed out at. And again, it won't show it to you here. It won't zero itself out here, but behind the scenes, it knows. So these will not get re-zeroed when you do that, but behind the scenes, the program knows what's going on, and it will then correct the rotation based on the 102 intake centerline we want for this particular cylinder. I've switched to our webcam here. I'm going to go over a little bit of the hardware here. What we got is the cam test stand, these B blocks the cam will set on its journals, and this slides obviously. This thing, I believe, is 32 inches long, so allowing 2 inches for each one of these, it'll handle a cam up to about 28 inches long. We have our linear encoder that's going to measure lift, and our rotary encoder. Now I want to show you something. First, let's on the rotary encoder. How do you install the rotary encoder? It's got this pilot, and that pilot it will go in the end of the cam, and it's got this sleeve. You can see that slides. So when you install the cam or the rotary encoder on the cam, I'm holding the magnet back towards the rotary encoder. So the pilot is sticking way out. I put the pilot in the end of the cam, and then I release the magnet. And then I let this bar fall down and be held in place by another magnet here, and I have the lead from the encoder going down this way to kind of put extra pressure to make sure that that stays in contact with that cam, or with that magnet, I'm sorry. Now some cams, like this one here, I'm holding my microphone, have a very small end on them. The rotary encoder is not going to stick with the magnet, it's not going to stick to that very well. So what we do, put my microphone down, is what you can do is get a little split collar. This one's too big, but you can put that on there, clamp that on. Now you have a much bigger flat surface for the rotary encoder magnet to stick on. So we use a split collar on the end of a small cam to make that work. Okay, let's get to the linear encoder. Linear encoder here, we are running with a follower directly on the cam. This is a flat tappet cam. We got a flat follower on it. We have our lifter bore holder here that is holding the lifter. And I'm going to put my microphone down again, try and talk. But a lifter I got a little magnet on top to make a nice flat spot for the pointer. If you put the pointer directly down in the lifter and it doesn't have a flat spot, it might be in the oil hole, it might be off to the oil hole, you get some non-repeatability because it can move around a little bit. So what I did here is I just put a little magnet on top, so it's got a nice flat surface. Some people are going to can take the plunger out and flip it over, so you got a flat surface there. I just happened to do this because it was quick. Um, when you put the I'm sorry, we're measuring number one intake first. Like our cam drawing says, here's number one intake. It's a third lobe from the front. So we got our lifter on that. We want to make sure that our lifter is not going to top out and go into bind here on our linear encoder and damage it. These are fairly expensive to replace. To repair is probably $150 minimum if it can be repaired, and replace it, you're talking about 600 bucks. So you don't want to damage this. Things that damage this is side loading. If you pushing and pulling to the side, you will definitely damage this. So you want to treat this like the precision instrument it is. We got a little lifter handle out here. That's an option. I think it's a $20 option from us if you want this little handle, and it's handy. If this tip comes loose, or if you install this lifter handle, you have to turn screw something onto the end of this shaft for the encoder. There's a little wrench that comes with your system, the box that holds the encoder. Use that wrench so you can clamp on here, and you do not put excessive twist torque on it. It cannot handle a lot of twist torque. So you want to really be careful with this. Okay, you want to make sure that this bracket that holds this is out perpendicular. It can't be off to the side, because that's going to pull the lifter back away from the cam. And the whole stand, is, when you get it, has been pretty much set up so that this will lie directly on the center line of the cam. You want the lifter to be directly on top of the cam. For a flat tappet like this, it's not that fussy. For a roller, it gets more fussy, because now the roller is going to be off to one side, back or forth of the cam. I mean, generally in back, because that's all you can do. Where this ends up, if it's a flat surface, is not that fussy. I could twist this off to the edge, and it's really not that fussy. Your lifter, you don't want your lifter hanging out excessively below the bore, and you don't want it excessively above the bore. Obviously, if it's excessively above, the adjacent lobes are going to hit the bore here. But if it's excessively low, then you could get some wobble. And again, on a roller, it's going to be more fussy. So something to look for. On this cam stand, we have our magnet locator. That's this little magnet here that you can flip in place, and it holds the cam from going this way or this way, falling off the V-blocks. And as you rotate, you can see it just kind of swings. The dowel pin comes around, it swings out of the way. If you rotate backwards, you can hear that beeping on the computer maybe, but it just swings itself out of the way. Now, it is possible, if you go this way, it is possible to, you almost have to try, but you can rotate backwards and see. Now I'm rotating backwards, I'm hitting the square edge. In most all situations, that's not going to happen, but it can. Just be aware of it. But this is a nice, simple way of locating the cam. It's inexpensive, and it's really convenient. Here's our black box. This is the actual box that does all the communications to the computer. Here's our computer cable on this side. And with power light, power's on. We got our power supply. We got our lifter, our rotary and linear encoders plugged into the box. And they are different specs on the connector, so you can't get them screwed up. And some of the very early boxes weren't marked, but we're marking the boxes rotary and linear for which is which. Now, when you want to measure your cam, you put the lifter on base circle so the nose is pointing down on the right cylinder. Make sure that the lifter isn't touching either the adjacent lobes, and you're ready to go. Now, I'm not measuring yet here, and you can hear it maybe beeping when I was rotating it backwards, but here I am, and you can see this is clockwise when viewed from the front. And when you want to measure it, just put it on base circle. It doesn't have to be exactly, but the nose pointing down, and we're ready to record. Okay, we're back at the screen here, computer screen, and if I just press F1 or click on F1, I press F1 because it's a little more convenient. Press F1, and you can see the timer take off. I'm rotating the cam, and like I said, you are not going to get very good data when I'm doing screen recording at the same time, because it just can't keep up. Can't do both things at once. But when it's recorded enough data, you can see here it's bad data. I mean, this is because of the screen recorder. But it says, do you want to remeasure this lobe? I'm going to say yes, and then I'm going to measure it again. Okay, I measured it with the screen recording off and it went fine. And you can see what happened here. Now it automatically jumped to exhaust number 1, which is shown here. And what we can do also, I just want to point this out, if you press F8, you'll jump back to the previous cylinder. Press F9, you'll jump forward to the next cylinder. But here you can see here's exhaust number 1 shown here being highlighted and exhaust number 1 up here. I'm going to back out of this screen. And let's see, you can see it drew our data here from that recorded profile on intake 1. And I just want to show you, here is the intake center line that we told it we want it 102. It's actually 101.99, which is 100th of a degree off. But it's at 102 degree center line. And all the other lobes we measure from now on are going to be referenced from this point, how the program has zeroed out the rotary encoder. And here you see the lift, duration, and all this other critical information. I'll get to that later, but I just wanted to show you this one is at 102.